Hello dear students, this is Issac Physics convenient current. Okay, so we have a conveyor belt of width 10 centimeter. So we have a conveyor belt that has a width of 10 centimeter, has a surface containing the electrons with the number density that is 10,000. So the total number of particles and number of charges is 10,000 per millimeter square. The conveyor belt is moving with the speed of 5 meter per second. So here is a conveyor belt. This belt has width 10 centimeter. So width of this conveyor belt is given, that is equal to 10 centimeter, that is equal to 0.1 meter, and the number density is 10,000. Area number density that is equal to 10,000 per millimeter square. So if we convert into per millimeter square is 10 power minus 3 meter square. That gives us 10,000 multiplied by 10 to the power 10 power minus 6. So here we have minus 2, so that gives us 10 power plus 6 meter power minus 2. Okay, because 1 millimeter is 10 power minus 3, so minus 3 and minus 3 makes the plus 6. So this is the area number density, mean the number of charges per unit area. Okay, the speed of the conveyor belt is given. The speed v is 5 meter per second. 5 meter per second. Okay, so if speed is given, then we can estimate the distance s by using this speed. Okay, first we calculate for the surface area. Okay, first we calculate for the surface, because we know that we want to find the magnitude of current. So in order to find the current, first we solve for the surface area. Surface area is equal to, as we know that surface area is length into width, so length is actually, this distance is actually the length into width, so distance s into w, surface area, and surface area per unit second per unit time is equal to distance s over second per second multiplied by width. So as our distance per unit time is actually the speed, that v into w. So the surface area per second is equal to speed multiplied by the width. Speed is given in the question, that is 5 meter per second. 5 meter per second, and the width of the conveyor belt is 0.1 meter, and we get 0.5 meter square per second. Okay, so this is surface area per second. Because this conveyor belt is moving, so that the speed is given, so we multiply speed with the width of this conveyor belt to get the surface area per second. Okay, now if we know the surface area per second, now we can find the number of charges by multiplying with the area number density. If you multiply area number density with this surface area per second, we get total number of charges. Okay, number of charges equal to number of charges is equal to number of charges or number of masses per second equal to area number density. We multiply area number density multiply with the surface area per second. So area number density is area number 10,000 to the power 10 power 6, 10,000 into 10 to the power 6 meter minus 2, and surface area per second is 0.5 meter square per second. So this meter square will be cancelled, so we are left with the number of charges per second, that is equal to 5 into 10 power 9. 5 into 10 power 9, that are charges per second, number of charges per second, number of charges per second. Oh, okay, now we find the total charge, total current, mean the current. So as we know that the Q is equal to NE, total charge is equal to number of charges multiplied by the E. So if we want to find the charge per second, that is equal to 1 ampere equal to number of charges per second multiply with the electronic current E. So the number of charges per second is 5 into 10 to the power 9 per second, and multiply with the electron. One electronic current is 1.6 into 10 to the power minus 19 coulomb. So we are left with the current I, that is defined as charge per unit time per second, that is I is equal to 8.0 into 10 power minus 8 ampere. Okay, now we can check this answer on Issac Physics. This is the correct. It is correct to two significant figures, because we round off to two significant figures, because you can see that our answer is round off to the two significant figures. Okay, now for the part B, we are given that the 3000 extra protons are produced. So if 3000 protons are produced, they are balanced by they equalize the number of electrons, 10,000. So first we have to subtract number of charges. Number of charges are equal to 10,000 minus 3000, that gives us 7,000. Because if 7,000 are protons, so they are equalized with the electron, they neutralize the electron, so we are left with the 7,000. So we follow the same steps, and with the 7,000, number density. So if we follow the same steps of 7,000, 10 power 6 is the area number density, 7,000 into 10 to the power plus 6 meter minus 2 is the area number density, and we multiply with the, we follow the same steps, we multiply with the surface area per second, that is 0.5 meter square per second, that 0.5 meters square per second. So we are left with the 3.5 into 10 power 9, 3.5 into 10 power 9 number of charges. So we apply Q is equal to NE, charge per second equal to number of charges per second. So that is charge per second is current I. So number of charges are now 3.5 into 10 to the power 9 per second, and we multiply with the electronic current 1.6 10 power minus 19 coulomb. So we get current that is equal to 5.6 into 10 power minus 10 in ampere. Okay, so this is part B answer. So correct to two significant figures again. So if we check this answer on this Issac Physics, so we can say that this is 8 into 10 power minus 10 ampere, and 5.6 10 power minus 10 amperes. Okay, thank you.